I'm not telling you until you try it first. No hint. Let's see who remembers last week. No, not quite that. You see, people kind of remember it, but not perfectly. Okay. Again, not quite right. Halfway there. And I take it you didn't watch the video I emailed to you. You're not too far away. Oh, you're close. You have some things right, some things backwards. Yeah. It's not working for you? I'm just taking after class and trying to fix it. Maybe you can just share. Do you have it? So again, people who don't read my emails, this is okay. I'm used to it.
Maybe I did.
Well, at very least, try to find someone who you can share with. It won't work if the two of you are here, so like maybe if you swap it in the middle here. You figured it out on time. Congratulations, you are number 2.
Somebody was saying actually. We tried all the errors possible.
So I see we're having limited success at the moment. So let me show you. Is that... Yes, it's turning on. Can you see? Yes? You'll all make terrible hackers, by the way. Yes. Yeah. I know my information is secure in this room. Okay, so let me show you. Data. We don't type equals. We type this. Oh, of course. And don't forget, you need the C. It's a way of telling the program it's a set of data. Yeah. So you've done that now? Yeah. Has everybody done that? So I noticed that some people, they forgot the C, and most people forgot that we don't use equal, we use the arrow. No. It should work. What are you doing wrong? Okay, so now that you have your data, did you get it? I want you to calculate from your data the mean, median, mode, lower quartile, upper quartile, interquartile range, standard deviation. Mean, median, mode, lower, upper, inter, standard deviation. Yes. Firstly, mean, median, mode. Lower quartile, upper quartile. Now, actually, Fahad, we haven't done that in physics or maths, so you can skip that part. Then after that, I want minimum and maximum as well, the min and max. So you know what the answer should be for that. It should be 1 and 5. Yeah, so mean, median, mode, lower, upper, inter, standard deviation, min, max, and range. Yeah, well I type it up on the screen so you can see it then. So what I want is, how do I do comment? Yeah. So I would like you to get the mean, the median, the mode, the lower quartile, the upper quartile, the interquartile range. Sorry, you've done that, haven't you? Interquartile range? Yeah, okay. Interquartile range, standard deviation, the minimum, the maximum, and the range. It seems so long ago. Wait, you weren't even in the class. So why don't you ask someone who was in the class? No one remembers anything I've taught them. That's okay. I teach engineers, so I know how that feels. Oh, sorry. You know what I'm talking about. Right, okay. So, firstly, you remember the mean is nice and simple. It's mean. So you got 3. Median. What did you get? 3 as well. Mode doesn't work this way. Now, lower, upper. Hey guys, listen, because you don't remember this. Does anybody know how to get the lower and the upper? Summary data. And you can see that, whoops, sorry. Minimum is 1, first quartile, median, mean, third quartile, and max. What do you mean it's not working? When you type in summary data? Did you store your variable as data, or did you store it as a different letter? Type in, what letter do you store it as? Type in data and make sure it's appearing properly. Like, do you get it exactly like this? 1, 2, 3, 4, 5? Are you sure? Okay, standard deviation. SD, very good. SD data, 1.58. Yeah. And what else did I ask you? Range. Does anyone know what the range is? Not quite. That's not quite the range. Range. Anybody? Wait, what? Range of this data. Oh, you're saying you think it's range data? Not quite. I mean, this is just saying it's 1 to 5, but that's not what I mean in statistics when I say the range. The range is the maximum minus the minimum. So the range is 4. Oh, and I haven't calculated the interquartile range. Not working still? Okay. I haven't calculated interquartile range. You can see that it's going to be 4 minus 2. Alright, so one other quick revision question. Let's imagine that data is in meters. And we would like to convert it into centimeters. So how can I convert this into centimeters? I want to make my data, let's call it new data. I want to make it like the old data but in centimeters. Maybe the old data is in meters. So what could I do? Try and make it first, then tell me. Okay, you remember how to do this?
No. This is my question.
Oh, I'm so embarrassed. My physics student. Come on, you know how to change meters into centimeters. Now, I would understand a biology student saying that, but a physics student, meters into centimeters? Times 100. Ah, yeah, but he's a biology student, so you can let that slide. Yeah. So it's like this. New data is data times 100. So when I type in new data, I get them in centimeters. And let's do summary new data. And you can see it's the same really multiplied by 100. Okay? Yes? Hey, listen. No, you shouldn't. Hey, listen. You shouldn't be talking right now. So we have this part done. So your brain should be reactivated to this now. So let's have a look at some new stuff. So as part of your assignment with me and with Joan, you're going to have to maybe have some numbers in a spreadsheet or some data like this. So if you have Excel, you can open up Excel. If you don't have Excel, you can open up Notepad. Okay? So I'm going to do this in both Excel and Notepad. So this should work for everybody because at least everybody has Notepad, but most people have some kind of Excel program. Okay, so let's open up one. Science students, what are you doing in maths at the moment? What was the last lesson? Ah, the tables in the formula book. So, binomial distribution, yeah, okay. Have you done everything on, you have drawn histograms yet? Yes. You've done histograms, yeah? And scatter plots? Yes. You've done them as well? Yes. Great, okay. Alright, so if you have something like Excel open, we'll make two variables and we'll just call them X and Y. So let's say X is 1, 2, 3, 4, 5, and we'll say Y is something like 3, 5, 7, 9, 11. So if you have Excel, I want you to type that in. If you don't have Excel, is there anybody here that does not have Excel? Yeah, so if you don't have Excel, you can do this in Notepad. So the way you would need to type it is X with a quotation and a comma, and then Y as well, and then you would have quote 1. It's a bit longer, but you get the idea. And then this is 2. It doesn't have to be Excel. It could be OpenOffice, LibreOffice. What am I at? 3, 4. Don't forget my commas. And 5. What was my first Y? It was 3, 5, 7, 9, and 11. Shh, please. So, if you don't have Excel, you can type your data in a text file like this. Notice, please, the quotation marks around each entry and the comma that separates each entry. Now, if you have Excel, you can do that just by typing it in. But you must save it as this type of file. I'll show you now. So I'll call the file data file. And you must not choose XL or XLS or whatever. You need to choose this one, CSV. And CSV is comma separated. Excel, all Office programs will let you save the file as a CSV file. So data file.csv. We'll save this to the desktop. Save. Now, you might get some prompt like this. It should be all fine. Yes, okay, I think this looks okay. So this is now saved to my desktop. There it is there. If I was to open this with something which was not Excel, if I just use a normal notepad program, it makes the same thing basically that we were typing. Sometimes you don't need to put the quotation marks in, but I really recommend that you do, because sometimes your data value might have a space or a comma in it. Like this could be my value of X's or something like this. So to prevent any confusion in reading the file, we should put quotation marks around everything. But something simple like this, you could probably drop the quotation marks and it would still open up just fine. Okay? But I think everyone here has a program like Excel, so just make sure you have it saved as CSV. So has everybody done that? Yeah, it's saved on your desktop or something like this? Yeah. Okay, so now, let me just close this version here. Oops. So we would like to read this data in. So the first thing we need to do is change to the desktop. So up the top here, let me see where it is. I think it's in Session. If you go to Session, Set Working Directory, Choose Directory is what you need to find. Try and find that on your version. No, in the OR program. Yeah. Have you all found it? So, if you click Choose Directory, you can then pick your desktop and pick Open. So what you're doing is you're changing your location to the desktop. So now this program will look for files on the desktop. Has everybody changed their directory to the desktop? You should get something like this on your screen now. Yes? Does anyone need help? Have you clicked Session? Have you got the program open? And you're on a Mac? And this is the reason I don't like Macs, because it's there. You have to put the mouse up the very top to make the menu appear. I don't have a Mac and I know this. Has the menu appeared up the top? You're making me get up off my seat. Josie, it's not under session. There's like a different title, is it? Or is it still called session? What did you do? Wait, do you have to highlight over or? Yeah. And then, dude. So, wait, this isn't Or Studio. You haven't installed Or Studio. This is just Or. You need to open Or Studio. Yeah. Okay, everybody's doing this? Yep. Right, so what we'll do is we'll try and read in this data file. Okay. So we'll put the data in some variable. We'll call it, I don't know, my saved data, whatever, or just data file. It doesn't matter. Okay. So to read in the data file, we type in the function read.csv brackets quotation mark. And we must put the file name here, which I think, I can't even remember what I called it, data file, wasn't it? Datafile.csv. Have you typed that? You've typed that, Fatty? Ah, okay. Yes, okay. Right. Now, we need another variable in here called header equals true. So what you're doing here is you're telling the function that your data file has a header, a first row which says the names. In this case, X and Y. Have you all done that? Yes? Okay, press enter. No, this is right. Yeah, there's a comma here separating the file name and this variable. That means you typed the name in wrong, or you didn't go correctly to the directory where it's saved. The file name must be an exact match. Have you done this? Yes? Yes? No? What's the problem? No problem over here? Yeah. So go up the top, and then you can pick session and set working directory as the desktop. Yeah, the desktop. Okay, have you done this? No. Just open. The desktop. Okay. Yeah, and then no. You open the folder. No, so it's just this. And then type in that command, but whatever the file name is, instead of datafile.csv. Have you done this? What's taking so long? Have you saved? Come on, save it and come on. Have you done this? Cool. Great. Okay, that's done perfectly. Good job. Right, have you done this here? Yes, it worked. And you've done this? Yeah, you saved that and then directory where you saved your data file? Desktop probably. Select folder. Have you done it there? Right, we'll continue. So we can make sure that this has worked because if we type in data file, we should get our data set. Double check that it's worked for you. Has it worked? Yeah. Now, suppose I would only like to look at the X values. The way you would do that is typing in data file $X or whatever the name is that you gave the first one. This will give me the X values in the data file. Or data file $Y gives me the Y values. Check it. Has it worked? Now please remember it's case sensitive, so if you use a big X, you should use a big X. Oh, you're still a step behind, is it? Have we done this? I don't know if people are confused, not listening, lazy, or all three. Is this part done?
Yeah.
I heard enough yeses to continue. Okay. So, what stuff have you done in maths when you have two data sets? And we've done this in physics as well. So what have you done? You have like an X data and a Y data. What have you done with them? Plot a graph. What type of graph is this called? Scatter plot. You've calculated what else? Linear regression. The equation of the line. And what else? What else? Maybe something called correlation? Just throwing it out there? Yes? You've done this stuff? Are you sure? Yeah? Okay. Now it's a little bit annoying to have to type data file $X every time I want X. So what you can do is type in the command attach data file. And what this lets you do is it means every time you're using X and Y, it's always from the data file. So you don't need to type data file. So if I did attach data file and just typed X, I'll get my X's. If I type Y, I get my Y's. I don't need to type data file $X, data file $Y. So you can attach the data file. It means the data file is the thing you're always going to be using now. So can you type that command in, attach data file? And then type in X and then type in Y and see if you get the same. So it's attach data file, or whatever you called it. Well, it won't work because I've already done it. So if you type in X and type in Y, do you still get your numbers? Yes? Have you done that? Have you managed to type in the one thing I asked you to type? Or is there problems? There's problems. Who's having trouble with attaching? Trouble? Yeah, but the data file is not called data file. It's probably called data file.csv. Or maybe lowercase csv. Well, where's the data file on your desktop? Okay, so it's data file. And, okay, open up 4 again. Have you set the working directory to desktop? Okay, data file. Did you try with lowercase? Maybe you can write space in here. It's maybe something because you've tried a couple of times and it hasn't worked. You might want to give it a new name. Hang on. Oh, you know the other thing is, it might not do it if the file's still open. Do you have the file still open somewhere? Yeah, close it and then try. Alright, we'll give it a watch. Here it is on here. Yeah. Okay, you'll just have to give this another go, maybe after a reboot or something. Try it again with datafile.tsv and double check the spelling, make sure there's not even one mistake. Okay, have you attached it? And the X and the Y produces the same values? Okay, so what we'll have a look at now is making the regression line. You know, finding the equation of the line and finding the correlation. Yeah. So what is this called in maths? This is regression, or linear model. So I'll call it my linear model. Type that. Have you done that? You haven't. I know. Has the person beside you done that? Yes? Okay. And physics students, we've done this as well in Excel. So this is how you do it in OR. Guys, hey, listen. Abdulaziz, listen. I don't understand why there's so much talking. I'm typing stuff and I want you to type the same stuff I'm typing. That's really all I'm asking you to do. There shouldn't be so much trouble. Yeah? So, data file, let's use it. The function we need is LM. This function is for making linear models. Brackets. So the only thing we need to tell our function LM is what we want on the y-axis and what we want on the x-axis. So what do we want on the y-axis here? Y. And what do we want on the x-axis? The x. So we type in y, then this symbol, a little squiggle. Yeah, you need to find that on your keyboard. No, it's a squiggle. For me, my squiggle is on the hashtag key. Squiggle, have we found squiggle? Yeah. The arrow. Oh, LM. Have you found squiggle? No, we're still at this stage. Alright, okay. Just try and make notes then of what I'm doing so you can try to get ready. Have you found squiggle? No squiggle on your keyboard? Oh, okay. Is that where yours? Yeah. Have you found it? There it is there. Have you found it? Have you found it? And have you found the symbol? Guys? Have you found the squiggle symbol? No, there it is right there. No, yours isn't there. Jesus. The one that looks like squiggle. Squiggle. Look. Where's the hashtag? Right. Have you found the key? Where is it on yours? Right. Where the heck is yours there? Where's your hashtag? There it is there, yeah. You found it? No, not this one, not that one. This one, squiggle. You might need shift and alt because it's this. Okay, uh-oh. Can we go back? Just close the thing that popped up. Maybe we can try it again.
What has been again?
Right. And X. Enter. Don't worry, I'll send you the video for this later. I'll email it to you, okay? Right, have you all typed that in? Yes. Now, what you've just done is you've told the program to make a linear model with y on the x-axis and x as the x on the x-axis. Let's type in my linear model and see what we get. What do you mean it's not working? Have you typed this in?
Yeah.
And did you get an error message?
Yeah.
What did it say? LM for linear model. Right. So if you look at your result, what you have here is this is the slope and this is the intercept. So this is saying y equals 2x plus 1. Okay? Yeah, what this result means is that y equals 2x plus 1 because this is the coefficient of x because it's under the x, and this is the intercept, which is the c. Do you understand how to read this? But what other things do you want when you calculate a regression line, a linear model? You also want the correlation and other things. So if I type in, I think, summary linear model, my linear model. There. Now, when you type in summary my linear model, you get this big summary table. Most of it you don't care about, but there is one value in it that you do care about, and it's right here. I highlighted it. R squared. Now, my example R squared is 1, and the reason it's 1 is because I made my data form a perfect line. This is why the R squared is 1. And you know this from physics. The nearer to 1 it is, the more accurately the line fits the point. So because the R squared is 1, it means my point and line perfectly lined up. Okay, and in fact it gave me a warning message because that never happens in real life. So you can see here it says, warning message, perfect fit, summary may be unreliable. So stuff in life doesn't work out that well. So this is why I gave you the warning message, okay? So you can type in summary. Okay, one last thing to do. What would we also like to make with our linear regression? So we have the line, and we have the R squared. Is there anything else we need? Yes, and the physics students know what the residuals are, so it's calculated the residual as well. Science students, you don't need to know what the residuals are. So you can see this program gives you all the information at once. That's why it's useful. Yeah. Anything else we would need for regression? Anything else you might need to do in your chapter on linear regression? The graph, yes. So actually, you know what? I think next time we'll have a lesson on graphs. So far, what you can do is mean, median, mode, lower quartile, upper quartile, interquartile range, min, max range, standard deviation. You can read in data. You can calculate the best fit equation line, and you can also calculate the R squared, the correlation squared. So the last few things to look at would be the histogram and the scatter plot. Is there anything else you've done that you might need to do? Oh, cumulative frequency. Have you done that one?
Yes.
Yeah, okay. So I think we'll have maybe something like 2 or 3 more lessons on this. So next time we'll have a look at graphs, okay? Have you started your assignment with Joan yet? No, so that's okay. So you have enough here to get a start on it. I think in Joan's assignment, one thing that you'll need to do is use the log function. And just to show you here, in OR, what's the natural log on your calculator? What function is that? ln. In this program, it's not ln, it's log, okay? So this is actually natural log. So for example, if I type in logx, what does it do? It calculates the log of all my numbers in x. Now physics students, you know that sometimes for some situations you need to calculate a log. So you can calculate the log of everything at once. Look, log(y). This will log all the numbers in the y. So there they all are there. See how quick that is? That is much quicker than going log 1, log 2, log 3. Physics students, you know we sometimes need to use log on our graphs. And science students, you will soon find out that sometimes you will need to use log on your graphs. So I wanted to show you this. Okay, I'll email you this video.